Hello everyone. Hello everyone who joined SaugaTalks today. I am Irene, if you know already. So today we will be talking with Imtiaz Adam, who is a known authority in artificial intelligence. Imtiaz is an AI executive and strategist. He has a pedigree in business and computer science. He's a known authority and influencer on Twitter in particular. If you don't follow Deep Learn 007, you should, because that's what I do, and that's where wisdom and knowledge coming from. So Imtiaz, welcome to SaugaTalks. Hi.
Thank you very much, Irene, for hosting me and inviting me.
Absolutely, this is my pleasure, because what we will be talking about today is AI. Surprise, surprise. Being here with expert of your caliber, I really want to understand a few things. How businesses should treat AI and what we're dealing with right now, because there are practical applications, there are use cases, but at the same time, there is adoption barriers.
Yes, no, thank you for that introduction as well. I think, first of all, if you kindly allow me to say a couple of words about myself, and thank you for that very kind introduction. I come from a bit of an unusual background in that I served as director of Morgan Stanley, the investment bank, and come from a business school MBA and mathematical finance background, but then I also went on to study AI and machine learning at postgraduate level afterwards with research in areas such as deep neural networks. I believe this is a very exciting area, but it's also one where we can get a bit carried away sometimes, in particular with some of the hyper expectations about what AI is and where it really is the reality of today versus where we think it's going to go in the future, or what the Hollywood movies tend to show. So I think coming back to focusing in on your point of AI and, let's say, machine learning, which is a bit of AI that really works in the real world, and deep learning, which is in turn a subset of machine learning, I think that's a good starting point to look at where we are, where we're going. So when you go back to the early pioneers of artificial intelligence, back in the 40s, /50s, I say 40s, you could say Alan Turing and others around that era, with the Turing machine, etc., and the Turing Test, right at the Turing Test, and in particular, and the Imitation Game, as it was called. And the Imitation Game was a game whereby if you had someone on the other side, I say someone, and it was actually a machine or a person, and the person speaking to it didn't know whether it was a human or a machine, and whether or not they could be fooled into or tricked into believing it was a human rather than a machine. And that's often referred to, that imitation game, as the Turing Test. And although there are some who claim that it's been passed today, many, myself included, but many indeed professors in computer science or AI would say it's not been passed yet. And the fact that it's still debatable tells you arguably it hasn't been, because if it had, it would be very clear. And that tells you, even as far as we've come, we've still got some way to go in AI in terms of being able to do things like common sense and understanding things like sarcasm, etc., that humans tend to do, to have a real general human conversation, in spite of where we are with the latest things like GPT-3 that we'll talk about in a moment. But if we take a step back, the early versions of AI in the 50s all the way up to, say, the 1980s, the types of techniques that were particularly prevalent then, and in the 80s, it was in particular the expert systems and things like symbolic AI or logic were very prevalent at that time. And the early types of algorithms that we had in that period, the 50s to, say, that period of the 80s, which have been things like the search algorithms, breadth first, depth first, etc., they were not really intelligent and they were brute force. We did then start to develop things like heuristics and things like the A-starred algorithm that were more less brute force and a bit more intelligent. However, none of those algorithms, and including things like the expert systems, really scaled well in a world that is not black and white, in a world that includes grey, a lot of grey. So deterministic systems that were prevalent in the early AI types of AI used in the early days tended to work well in deterministic situations where the world was either white or black. But as we know, there's a lot of uncertainty in the real world, and so they didn't really scale well. And then we came to the era of machine learning in the 90s and early 2000s, and then after that, deep learning, albeit deep neural networks have been around for longer than that, with the early architecture of neural networks going all the way back to the work of the perceptron with Fred Rosenblatt and others. I think a couple of research scientists from the former Soviet Union and Ukraine in the 1960s as well, and early 70s. And then the work by Jeff Hinton and Rumenhart and Jeff Hinton in 1986 with their paper in Nature, which kind of brought back propagation. Now, if we look at machine learning essentially is applying data and learning from that data. And it is a subset of artificial intelligence. And likewise, deep learning in turn is a subset, arguably, of machine learning, according to many. So AI is like the general umbrella that we catch all these things under. Deep neural networks refer to neural networks which were loosely inspired by the brain, the biology of the brain. And they're called deep because they have several hidden layers between the input layer and the output layer. Otherwise, it would be a shallow neural network. And these are deep neural networks have really driven a lot of the revolution in AI over the last decade, and things like computer vision with convolutional neural networks, with text to speech or speech to text rather, and neural translation with what used to be recurrent neural networks and LSTMs, but now is increasingly transformers with attention mechanism, of which GPT-2 and GPT-3 are types. And what's led to this move forward with advancement of AI, in particular machine learning and deep learning, has been the advent of large sets of data as we've moved to this era of digital. And if you think about it, the advent of smart mobile phones, the internet, etc., and social media has led to explosion in data. In fact, I think IBM have a statistic which they've released in the past that 90% of human data in the history of humanity was created in the last 2 years, and that keeps on changing all the time as we get more and more vast amounts of data. Then you look at someone like Statista, the consulting company, who point out that in the period to 2025, or by 2025, we will have forecast to have 75 billion connected devices, internet connected or IoT devices. That's an average of 9 per person on the planet. That's huge, which is going to generate vast amounts of more data. And what machine learning and deep learning do very well is basically making sense of that data. It's too fast for humans, it's too big, the velocity, the veracity, the volume. And therefore making sense of that data and then having the human analyst or the human team being able to take actions on the basis of that data or actionable insights. Some of which is true, some of this insights will be automated. For example, you can have sensors and make automated responses to what you detect from that sensor. But in other cases, you may be looking at analytic tools where you're looking at data, historic data that the machine learning can make sense of, and then you try to make a decision based on that or validate that decision. So it's not necessarily machine learning or deep learning replacing doctors or humans. Doctors, I gave that example where it's been cited before by some researchers that, hey, a radiologist will be replaced by deep convolutional neural networks. Or, well, actually, maybe it's going to be that we help the radiologist and others and dermatologists, etc., do their jobs more efficiently and take the strain off them rather than necessarily replace them.